In this video, we are going to discuss about different topics of welding. First one is heat affected zone in welding. It is the portion of metal adjacent to the fusion zone which is not melted but metallurgically affected by heat is called heat affected zone. The chemical composition of heat affected zone is same as the base metal but its properties and structure have been altered by welding heat. The size of heat affected zone depends on the welding methods and nature of weld being welded. The structure of heat affected zone for low carbon steel is shown in the figure. Here we can observe heat affected zone. In these different zones are available. First one, this blue color thing, it is called weld bead. It is a molten state of base metal and filler metal. After solidification it forms weld. But adjacent to this one solid liquid boundary we can observe, that is this yellow color region. After this one and up to base metal, this region, we can see this is heat affected zone. In this again we can classify this heat affected zone into different regions. First one is grain growth zone, that is in this we can observe larger grain structure. Besides this one, recrystallization zone. In this we can observe entirely change the structure of grains, that is new grains will form in this zone, and beside this zone partially transformed zone. In these less size grains we can observe. After that tempered zone, in this metal will be heated up to lower critical temperature. After that it will be cooled. Due to this one it will subjected to tempering operation. After that heat will not sufficient to change the grain structure. That's why this zone will be as similar as the base metal. This is entire region is base metal. Because of this heat affected zone, the strength of weld will reduce, and at the same time it increases the brittleness of weld. Due to increasing the brittleness, the strength will reduce and suddenly it may break whenever we apply this welded joint for any application. Next topic is welding defects. In these different types of welding defects are there. Out of those main welding defects we can discuss in this video. Those are, first one is slag inclusion, second one undercut, third one porosity, next incomplete fusion, after that hot cracking, next cold cracking, finally laminar tearing. Next we will discuss each defect. First one is slag inclusion. Slag inclusion is nothing but entrapment of slag within the weld. This is caused due to inadequate slag removal between runs or electrode removal, and incorrect joint design, and due to low current supply and improper techniques like nozzle tip angles and electrode positions and slow travel rate of electrode. These causes the slag inclusion welding defect. To prevent this slag inclusion, we can increase current supply and we can increase travel rate of electrode or nozzle tip. But if already formed slag inclusion, we can remove by grinding or other mechanical processes. Here we can see slag inclusion image. In this it is the pure weld and it is the slag inclusion region. This is a defect. Next defect is undercut. Undercut, it is a groove cut at the toe of the weld which is left unfilled. This caused due to high current supply and wrong electrode angle and long arc length between electrode and workpiece and rust formed on the workpieces, large electrode diameter and high welding speeds. This we can prevent by using clean metal before welding process. That means we have to clean the surfaces of workpiece. By doing that one, we can avoid the undercut defect. And in in the repair case, weld with small electrode at that particular undercut area. Then we can remove or we can fill that region, and we can do weld at that particular place. By doing this one, we can repair that undercut defect. Next one is porosity. Porosity is nothing but holes formed due to entrapment of atmosphere gases at the weld zone. And these are formed due to different reasons. First one is dampness in the flux coating. Dampness is nothing but wetness of the flux coating which is coated on the outer surface of electrode. And another main reasons are impurities on the surface of the metal and wrong type of electrode. To avoid these porosities, we can use proper electrode with a dry condition and dry electrode and clean metal. Before doing welding, any welding, we should clean workpieces or base metal surfaces. And in case of gas welding, keep nozzle above the weld metal such a way that will eliminate the porosity. Here we can see different pores. These are the pores present in a welding. Next defect. Welding defect is incomplete fusion. This name indicates that fusion is not completed. Here we can see this is a incomplete fusion zone. And here also we can see incomplete fusion zone. It is nothing but weld metal does not form a cohesive bond with base metal. This region is called incomplete fusion zone. The causes for this incomplete fusion zone are less supply of current and steep electrode angle, fast travel speed of electrode or the nozzle tip, short or gap between electrode and workpiece, lack of preheat, and electrode too small, unclean base metal. If we preheat the workpiece or parent metal, then we can eliminate this incomplete fusion defect. For in case of every welding process, if we do cleaning of base metal, then we can remove many defects. We can avoid many defects. And prevention eliminate the potential causes in the sense if you clean base metal or if you reheat, if you preheat, if you do all these, if you eliminate all these causes, indirectly we can improve the welding without forming incomplete fusion defect. And in case of repair, remove and re-weld these incomplete fusion welded zone. Next one is laminar tearing. It appears as a long and continuous visual separation line between base metal and the heat affected zone, caused by the presence of elongated inclusions such as manganese and iron in the base metal. By the weld configuration, which gives rise to high residual tensile stresses in the transverse direction, this also causes laminar tearing. Next defect is weld cracks. Weld cracks are nothing but discontinuities in the weld zone, generally results from stresses caused by expansion and contraction. These can be avoided by using filler metal which match the base metal composition. These weld cracks are basically two types. First one is hot crack. It occurs at high temperature and can be prevented by preheating the base metal. Next weld cracks type is cold crack. It occurs at room temperature after welding is completely cooled. This type of welding we can eliminate by stress relieving treatment immediately after weld is made. Our next topic is soldering. What is soldering? Soldering is a process in which two or more metal pieces are joined together by melting and flowing a filler metal into the joint. The filler metal having a relatively low melting point. In this, we can discuss main terms. First one is solder. What is solder? Just now we have discussed about soldering process. Solder is a fusible metal alloy with a melting point ranges between 90 to 450 degrees Celsius, used in a process called soldering where it is melted to join metallic surfaces. It is especially used in electronics industries. Generally used solder materials are metal alloys of tin and lead. In these, major alloy is 63% tin and 37% lead alloy. And these solder alloys consist of melting temperature less than 450 degrees centigrade. And, and different types of solder metals we can use. Those are tin lead alloy, tin silver lead alloy, and tin zinc alloy, silver copper zinc alloy, and zinc aluminum alloys. These are different types of solder materials. Soldering methods. Soldering In case of soldering, we can use different methods. First one is soldering iron, second one is dip soldering, third method is wave soldering. All are familiar with soldering iron method. In this, we will use one soldering iron. It is generally made up of copper and it will be heated by using electric resistance phenomena or by heating that soldering iron in a furnace. It is a tool. Soldering iron is a tool and normally used for applying heat to two or more adjoining metal parts, such that solder may be melt and flow between these parts due to capillarity action and binding them securely and conductively. Next method is dip soldering. In this case, we will join two metals by doing cleaning process. First of all, we have to do cleaning of these two plates. After that, we have to arrange them in the required joint manner. Then we have to place these two parts in the pool of molten solder. Then after that, we have to remove these two metal parts which will be joined in the pool itself. Next method is wave soldering. In case of wave soldering, parts which are to be soldered are not dipped into the molten solder pool, but a wave is generated in the tank so that the solder comes up and makes the necessary joint between the two metal pieces. Next one is advantages of soldering. These soldering methods having their own advantages compared to welding process. First one is joining dissimilar metals and non-dissimilar metals. That is the main advantage of soldering. It can be useful for joining dissimilar and dissimilar and non-metals also. And next one is here we will use low temperature compared to welding. That is one advantage. And here we can get less thermal distortion between the two metal parts or two joining parts, and less chance of damage. That is one advantage in case of soldering. And speed of joining, we can do very quickly this soldering process, and less manual skills required. These all are the advantages of soldering, but these also have some limitations like less strength compared to welding process and damage under high temperature conditions. These are the some things regarding soldering process. Next, we will discuss brazing process. What is brazing? It is similar to soldering, but main difference is the filler material melting temperature will be more than 4 degrees centigrade. Here, what is brazing in the sense joining of different materials by using a number of brazing alloys at temperature above 450 degrees centigrade is called brazing process. Different types of brazing process are available. Those are torch brazing, furnace brazing, dip brazing, induction brazing, and resistance brazing. Let us discuss each brazing process. First one, torch brazing. In this, we will heat the brazed metal by using gas flame torch. Here flux is applied. In this process, flux is applied to the part surfaces and a torch is used to focus against the work at the joint. A reducing flame is used to prevent the oxidation to avoid the defects. Second one, furnace brazing. In this case, we will place the two workpieces or two base metals in the required manner, and then after pouring this flux material and brazing metal and placing the brazing metal on the top of arranged joint, and we will keep this joint in a furnace and we will heat the entire setup. Then due to the temperature, due to the high heat energy supply, this joint will form. And next one is deep brazing. In this, assembled parts are typically dipped in a heated chemical bath which serves as a both fluxing agent and heat source to melt pre-applied filler material. And next one is induction brazing. Here the heat required to melt brazed alloy is generated by the phenomena of induction. For this we have to supply high frequency AC field. Due to that, induction phenomena will happen, and because of that induction phenomena, high amount of heat will release in the joining metals itself, and finally we can get brazed joint at the two workpieces. Next one is resistance brazing. In this resistance brazing, we will heat two workpieces by using electricity because of the resistance phenomena, that is resistance because of the resistance offered by two workpieces, heat will release. Because of that heat, already applied brazed alloy will melt, and finally we can get brazed joint between the two workpieces. These different types of brazing methods are classified based on the heat source supplied, based on the heat energy supply. Next one, in this brazing process we can use different types of filler materials. Those are generally copper alloys, but other than copper alloys we can use aluminum alloys or silver and nickel alloys. In case of copper alloys, major alloys are bronze and brass. Bronze, it is a combination of copper and tin, and brass, it is a combination of copper and zinc. These are the main alloying elements we can use while doing brazing process. And here these copper and aluminum will be alloyed with phosphorus, manganese, and magnesium and silicon to improve the brazing properties. And next, coming to advantages of brazing, these are almost similar to soldering advantages, but compared to soldering, here we can get higher strength, that is more strength joint we can get in case of brazing. And remaining advantages like here speed of joining will be more and less chance of damages, less thermal distortion we can obtain between the two workpieces, and low temperature compared to welding. This is also one of advantage. Joining dissimilar metals and non-metals also we can do in case of brazing also, like soldering process, and less manual skills required in case of brazing. These all are the advantages of brazing process. Okay, thank you.